Usually, like when you look up at the night sky, you are looking at this giant, predictable clockwork mechanism.
Right, it feels super orderly.
Exactly. I mean, we have our planets locked in their designated orbital lanes, the local asteroids reliably tracing their belts, and even the comets, operating on these long but mathematically certain repeating loops.
Yeah, it's a closed system.
It really is. We track it, we model it, and it feels incredibly safe. But then an event comes along that completely shatters that illusion.
It really does. It's a total wake-up call.
Yeah, because suddenly something tears through our solar neighborhood, blowing past all the cosmic stop signs, and you realize the clockwork is just a localized bubble.
Just a tiny drop in the bucket.
Right. Our cozy little system is actually sitting right in the middle of a massive, chaotic, cosmic superhighway.
Which is equal parts terrifying and fascinating.
Totally. So welcome to today's deep dive. We have our hands on a really fascinating excerpt from an article titled The Third Voyager, The Mystery of Three-Eye Atlas.
It's a wild read.
It really is. It details this monumental astronomical event from July 2025. And our mission today is to unpack the arrival of only the third confirmed interstellar object ever detected in human history.
Which is just a staggering reality check, honestly. I mean, in all of recorded human history, centuries of pointing glass at the sky, we have only ever officially caught 3 of these passing through.
Just 3.
Yeah. And the arrival of Three-Eye Atlas, well, it's pushing the astronomical community to the absolute limit.
I can imagine. I was looking at the timeline of the detection, and, this isn't just a rock floating aimlessly in the void. This is a fleeting, one-time-only messenger from an entirely different star system.
A literal alien artifact, naturally speaking.
Exactly. Okay, let's unpack this. The discovery happened in July 2025. Standard survey telescopes flagged an object entering our solar system, but its telemetry immediately broke the local rules.
It didn't fit the models at all.
Right. It wasn't born from the primordial dust of our own sun, like, ordinary comets or asteroids. It was flung out to the galaxy long before it ever reached our neighborhood.
The initial data was just stark. I mean, when astronomers calculate the orbit of a new object, they look at a value called eccentricity.
Okay, the shape of its orbit?
Exactly. An eccentricity of 0 is a perfect circle. And anything between 0 and 1 is an ellipse, meaning the object is gravitationally bound to the sun.
So it's stuck here.
Yeah, it will eventually loop back around. Even comets from the Oort cloud, they might have an eccentricity of, say, 0.99.
Which is a super long stretch.
Right, they swing out incredibly far, but the sun's gravity always reels them back in eventually. But the telemetry for Three-Eye Atlas returned an eccentricity significantly greater than 1.
Wow.
Yeah. That dictates a hyperbolic trajectory.
Meaning, well, the math itself proves it is not bound by our sun's gravity.
It fundamentally cannot be. The object possesses just way too much kinetic energy. To put it in perspective, for an object at Earth's distance to escape the sun's gravitational pull, it needs to be traveling at roughly 42 kilometers per second.
Okay, that's the local speed limit.
Right. And the observations of Three-Eye Atlas showed it moving at a velocity far exceeding that limit.
So it was just booking it.
Absolutely. That excess velocity is the undeniable fingerprint of an interstellar origin. The energy required to move that fast couldn't have been imparted by anything inside our solar system.
It had to have a running start.
Exactly. It had to enter our system already moving at an extreme velocity.
I think the best way to visualize this for you, the listener, is to imagine living on a quiet, closed-off cul-de-sac.
That's a great way to look at it.
Yeah, like most cars, which represent our local asteroids and planets, they circle slowly around the center, maybe pulling into a driveway here or there.
They clearly belong to the neighborhood.
Right, they live there. But Three-Eye Atlas is like a car blowing through that cul-de-sac at 100 miles per hour, ignoring the curbs, driving over the lawns.
Just tearing the place up.
Exactly. It's blatantly obvious it didn't start its journey in our neighborhood, and it is absolutely not hitting the brakes.
No, and pushing that analogy further, the sheer momentum of that car tells you something about the engine that built it.
Oh, interesting.
Yeah, Three-Eye Atlas formed around another star under completely different gravitational and chemical conditions, and then suffered some massive orbital disruption.
Like getting kicked out of its own house.
Essentially, yes.
Yeah.
Perhaps it was ejected by the migration of a gas giant in its home system, or, maybe the death of its host star. It was violently thrown into the interstellar medium.
Where it's just been coasting.
Right, likely traveling through the dark, frozen void for millions or even billions of years. It just happened to cross paths with our sun on its journey.
Which means it's just passing through. Once it slingshots around our star, it is gone for eternity.
Gone forever. It will never return.
Man.
The trajectory is entirely open. We have this incredibly narrow, fleeting window to observe it before it fades back into the deep interstellar void.
And that urgency, it's got to be compounding the mystery, right? Because the physical characteristics of 3I LAS are totally defying our expectations. Oh, completely. It's throwing everyone for a loop.
Yeah, because tracking a fast-moving dot on a hyperbolic trajectory is one thing. Actually figuring out what that dot is made of, while it's literally sprinting away from us, seems like a completely different logistical nightmare.
It is a massive headache for astronomers.
Here's where it gets really interesting. Because 3I Atlas isn't just fast. It breaks the incredibly small baseline of knowledge we have about interstellar visitors in general.
Which, to be fair, is a very small baseline.
Right. We only have 2 prior examples to compare it to. There was Oumuamua, discovered in 2017, and Comet Borisov in 2019.
And the contrast between those is jarring.
Yeah, tell us about that.
Well, Oumuamua was weird. It was highly elongated, possibly shaped like a cigar or a pancake,
Like space frisbee.
basically. And it exhibited non-gravitational acceleration, meaning it was speeding up in ways gravity couldn't entirely explain, yet it showed no visible outgassing, no tail at all.
So just a bare rock acting weird. Exactly. Then came Borisov, which looked and acted much more like a classic familiar comet. It had a tail, it outgassed, it felt recognizable.
And now the source text notes that 3ILLS seems to be significantly larger than both of those previous visitors. It's this massive entity barreling through our space.
A total behemoth compared to the other 2.
Right. But what really caught my attention was the detection of a coma.
Ah, yes. The gas cloud.
Telescopes picked up that familiar shroud of gas and dust surrounding the nucleus. And in our local comets, when they get close to the sun, solar radiation causes their surface ice to sublimate, right? Turning from solid directly into gas.
Which creates that glowing coma we see.
Exactly. So the immediate assumption is that 3ILS is behaving like a local comet, but I want to challenge that comet-like assumption for a second.
Go for it.
The article stresses that its exact composition and origin remain deeply uncertain. So, if it has a coma, does that actually mean it's made of the same stuff as our comets? Or could this be some fundamentally alien chemistry just masquerading as a familiar comet because it happens to be reacting to the sun's heat?
What's fascinating here is that you've hit on the exact paradox driving the current observational frenzy.
Really?
Yeah. Outgassing is an effect we recognize, but the underlying cause, the actual chemical makeup of the sublimating ice and dust, could be entirely foreign.
Because it didn't form here.
Right. Our local comets are rich in water ice, carbon monoxide, and ammonia. But 3I Atlas was forged in a completely different protoplanetary disk.
Totally different ingredients in the kitchen.
Exactly. The elemental abundance of its home system could be radically skewed compared to ours.
So it could basically be wearing a comet costume. I mean, it looks like one, but the fabric is woven from completely different material.
That is a perfect way to put it. And the only way to see through that costume is via spectroscopy.
Looking at the light.
Yeah, astronomers capture the light from our sun that passes through the coma of 3I LAS, or bounces off its dust. Different chemical elements and molecules absorb and emit light at very specific, unique wavelengths.
Like a barcode.
Exactly like a barcode. By breaking that light down into a spectrum, scientists can look for absorption lines, which are essentially dark gaps in the rainbow of light that act as chemical fingerprints.
Oh, that's clever.
It is. If the carbon-to-oxygen ratio, or the isotopic signatures in that coma, differ wildly from local comets, it confirms we are looking at material forged in an alien crucible.
But getting that spectroscopic data isn't exactly easy when the target is moving this fast, right? I mean, it's only visible for a few months. The clock is ticking relentlessly.
It is a mad dash.
Within weeks of its discovery, the article mentions its behavior was raising serious questions. But there is no time to plan a space mission. You can't just spend a decade building a probe to go intercept something moving at this velocity.
Oh, the kinematics simply don't allow it.
It's just too fast.
Way too fast. By the time an interception mission could be launched, 3I Atlas would already be beyond the orbit of Jupiter.
And getting darker.
Rapidly. Its brightness drops by the inverse square of its distance from the sun. It just becomes too faint to study.
So no probes, what do we do?
That creates an all-hands-on-deck crisis in observational astronomy. Time on major instruments, like the James Webb Space Telescope or the giant ground-based observatories, is meticulously scheduled years in advance.
Oh, right. Scientists wait forever for telescope time.
They do. But when an object like 3 Atlas appears, Observatory directors have to use discretionary time to override existing schedules, pivot those massive mirrors, and capture the data before the object disappears forever.
Wow, they literally drop everything. It's a scientific scramble, unlike almost anything else. So what does this all mean? Why disrupt years of planned science just to look at a fast-moving, dusty rock for a few fleeting weeks?
It sounds a bit crazy when you say it like that.
It kind of does. To me, it's like, I don't know, sitting in your living room in the dark for years. You finally turn on a flashlight for the very first time and you realize strangers have just been silently walking through your house this whole time.
That is a very eerie but accurate visual.
Right.
If we connect this to the bigger picture, the justification for that scramble becomes obvious.
Yeah.
Humanity has spent decades and billions of dollars trying to understand how planets form.
The big questions.
Right. How solar systems coalesce from swirling disks of dust, and ultimately, what conditions are required for life to emerge.
But we only have one test subject.
Exactly. Our models are fundamentally constrained because we only have a sample size of one, our own solar system.
Yeah.
We can point telescopes at distant, nascent star systems, but we can only observe them from light years away. We can't touch them.
We can basically only study the dirt in our own backyard.
Until an interstellar object arrives. 3I Atlas is a direct sample of a distant protoplanetary disk delivered right to our doorstep.
Wow. A free sample.
Exactly. The dust and gas in that coma represent the raw, ancient building blocks of an alien world.
That is wild to think about.
By analyzing its chemistry, we aren't just categorizing a rock. We are mapping the chemical diversity of the galaxy.
So it's way bigger than just one object.
Huge. If we find complex organic molecules, the precursors to amino acids in life, in the outgassing of 3I Atlas, it profoundly impacts our understanding of how common the ingredients for life might be across the Milky Way.
So it's like proof of concept that the chemistry we think is necessary for life isn't just a local anomaly.
Yes, it could be everywhere.
But here is the part of the source text that genuinely gave me pause. It points out that this is only the third confirmed interstellar object we have ever detected.
Yeah, 3 in all of history.
And that leads to a deeply unsettling realization. If these objects are passing through, and we've only caught 3 in the last decade, it forces you to wonder, how many more have silently passed through our solar system entirely undetected before our technology caught up?
Oh, millions.
We've just been blind to the traffic on the highway.
This raises an important question about our own technological infancy, rather than the rarity of the objects themselves. I mean, the universe didn't suddenly start throwing rocks at us in 2017 when we found Oumuamua.
Right, they didn't just start showing up.
No. What changed was the deployment of wide-field survey telescopes, like Pan-STARRS, and the anticipation of even more powerful observatories like the Vera C. Rubin Observatory.
Our tech finally got good enough.
Exactly. Historically, telescopes had incredibly narrow fields of view. They were basically like looking through a drinking straw.
So you'd have to be insanely lucky.
You would only see a fast, faint object if you happen to be looking at exactly the right patch of sky at exactly the right time.
Which is statistically almost impossible given the size of the sky and the speed of the objects.
Right. But modern survey telescopes scan massive swaths of the sky continuously. They use automated software to detect movement against the background stars.
So we finally opened our eyes wide enough to perceive the environment we actually live in.
That's beautifully put. For billions of years, our solar system has been moving through the galaxy, orbiting the galactic center. It is a mathematical certainty that countless millions of interstellar objects have passed through our space while humanity was completely unaware.
That is just staggering.
They drifted past Earth while the pyramids were being built during the last ice age, and long before humans even existed.
That totally reorients how you view our place in space. I mean, we naturally think of the solar system as a walled garden protected by the sun's gravity.
A safe little bubble.
Right. But the gates have always been wide open.
The interstellar medium, the space between the stars, is not an empty void.
It's busy.
It is a highly dynamic shared environment. It's populated with debris, planetary shrapnel, and nomadic comets.
And 3IE Tellus is just the latest tourist.
It is simply the latest, and perhaps the largest, of these cosmic travelers that we happen to have caught on camera. It proves that our solar system is constantly sweeping up material from the wider galaxy as we move through it.
Let me summarize where we are with this, because there is a lot of complex science to process here.
That's a lot to take in, yeah.
So today we've explored the arrival of 3I Atlas, which is this massive, fast-moving stranger from another star system that was detected in July 2025.
The third Voyager.
Right. And we know it's alien because its extreme hyperbolic velocity proves it is immune to our sun's gravity, slingshotting through our neighborhood on a permanent one-way trip.
Never to return.
Physically, it's confounding, right? It's shrouded in a coma of gas and dust that implies it behaves like a local comet, but its actual chemical composition remains a mystery that spectroscopy is desperately trying to solve.
Before time runs out.
Exactly, because it's leaving us forever, so the astronomical community is in this all-out sprint to gather data that could give us a literal free sample of alien planetary building blocks.
A once-in-a-lifetime chance.
And most importantly, its arrival shatters the illusion of isolation, proving our solar system is really just a rest stop on a very busy cosmic highway.
The implications of that busy highway extend far beyond just mapping orbital trajectories, too. It forces us to reconsider the history of our own planet.
I love that point. Before we wrap up this deep dive, I want to turn it over to you for one final thought.
Okay.
The source text leaves us wondering about all those undetected past visitors that slipped by in the dark. Where does your mind go when you extrapolate on the idea that this cosmic highway has always been open?
Well, it leads to a profound, almost provocative possibility regarding the origins of life itself.
Oh, wow. Okay, let's hear it.
We discuss how an object like 3I Atlas might hold complex organic molecules in its coma, and how countless millions of these objects have traversed our solar system over the last 4 billion years.
Right, millions of them.
If you look back at the early days of Earth, our planet went through a period of heavy bombardment by meteorites,
Just getting pummeled.
nonstop. And that violent era is largely credited with delivering much of the water and the foundational organic compounds that eventually made life possible.
Basically seeding the Earth.
Yes, we have traditionally assumed that those life-giving meteorites were local, asteroids and comets originating from within our own solar system.
Our own debris.
But if the interstellar medium is this crowded, and our solar system has been sweeping through it for billions of years, is it possible that some of the ancient meteorites that struck early Earth weren't local at all?
Wait, really? You're saying they came from outside?
Think about it. What if the very spark of life, or at least the raw chemical precursors required for it, were delivered by interstellar travelers just like 3I Atlas? Objects that didn't just pass through, but actually collided with us.
That fundamentally shifts the perspective.
It really does.
We wouldn't just be living next to a cosmic highway. We might actually be the descendants of the cosmic hitchhikers.
Exactly. It suggests that the building blocks of life could be a shared galactic heritage distributed across star systems by these nomadic rocks.
That is an incredible thought to leave on. Like we established at the start, you think the night sky is this predictable, closed clockwork mechanism until a stranger, like 3A Atlas, tears through the neighborhood and proves we are part of something much larger, far more chaotic, and deeply interconnected.
There's a big, messy universe out there.
It really is. Thank you for joining us for this deep dive into the mystery of 3A Atlas. We hope you take that final thought with you the next time you look up at the night sky. Keep questioning the universe around you. Until next time.